Next, we're going to look at how to solve logarithmic equations. And a logarithmic equation is an equation containing a variable in a logarithmic expression. Okay, so something such as, for example, log base 3 of x plus 7 equals to 2. So this is an example of a logarithmic equation. So steps to solving a logarithmic equation. Number one, it says express the equation in the form log base b of m is equal to c, meaning we want the log by itself on one side. Okay, and this is an equal sign. Okay. And then it says we're going to use the definition of logarithm to rewrite the equation in exponential form. So what we're going to do is take this logarithmic equation and write it as an exponent. So remember, identify the base. So you're saying 3, and then what is it equal to? That would be your power, the answer here, 2 equals to the x plus 7. So we have 3 raised to the power of 2 equals to our answer x plus 7. Okay, so this is how we would convert from log form to exponential form. That was one of the first concepts that was taught in section 4.2, how to write both of these, go in both forms. And then we would take this exponential form and solve for the variable. Now, number 4 is going to be key, and we're going to be doing some examples where you may not have a solution. Okay, and here's why. It says check proposed solutions in the original equation. Include in the solution set only values for which m, I'm pointing to my m in the log form, is greater than 0, meaning it needs to be positive. It says always check proposed solutions of a logarithmic equation in the original equation. Exclude from the solution set any proposed solutions that produces the logarithmic of a negative number or the logarithm of 0. So what this is saying here is that your m component in this particular statement, so we have log base b, let's say that the m was a negative 7. We would say that we can't have a negative number here. We would say that's no solution. Or if we had log base b of 0, we would say that solution would be excluded. Okay, if we go back to intermediate algebra where we talked about extraneous solutions. Yes, we were able to solve it, get an answer, but when we go back and check our work, it does not present itself. It's not equal to. So underline this part. This is very important. Okay, exclude from the solution set any proposed solution that produces the logarithms of a negative number or a logarithm of 0.